Welcome to the Ethereum smart contract tutorial. So this is the first tutorial I'm posting there, and I am also learning side by side. So just thought to post my learnings, and so I've been trying to build this very basic app from last 2 days, but I ran into some issues. So I thought to create this tutorials with my learning so that someone out there may find this helpful. So today what I'll do is I'll create a very simple smart contract and connect it to your front end web app basically, and see how the interaction happens and how we can see the value from the smart contract into our website. So for today, since this is the first time, I am also guessing you guys are learning. So we'll go very baby step. We start with very baby steps and then move on to advanced things. So if you have, so first thing you need to do is install truffle. You can just simply Google it. I already have this installed in my system. I'll open my terminal, go to my workspace directory. Here I'll create a new directory, mkdir. Uh, so let us suppose I give my project number play. So this is the directory I am creating. My project name is number play. I'll go inside the directory and simply do truffle init. So truffle, basically if you are into smart contract development, you will see that truffle is like very much very good actually for smart contract development, and it has made things very easy for the developers. So you can just go and do truffle in it, and it will create various files for you, so you don't have to worry about compilation, deployment and all that. It will handle all that for you, so you can concentrate on developing your smart contract. So it has like created some files for me. Let's go ahead and look at those files. So I am using Atom for now. You can use any of the ID. So these are the files. First is contracts. Under contracts we have migrations.sol. Then we have a migrations folder, then we have a test folder and truffle config.js. So if you want to create some contracts, you can directly go into the contract directory, create a new file. So let's say I'm creating a new contract, my magic number dot sol. Press enter. So this will create a new contract. So migration.sol is basically a very special kind of contract used for migration purposes. We'll leave that alone. We'll start coding our contract. So we'll use pragma solidity and 0.5.1. So this line tells the system basically which compiler to use. So our code will be compiled against this version of Solidity. Since Solidity is in rapid development, we need to make sure to choose the latest stable version to take benefit of the latest features. And this tells the compilers that to at least use this version or greater than this version. Next, we are going to create our contract, and you can understand this contract as basically a class which will have your behaviors and state. And if you are coming from a Java background or any object oriented background, so you can understand this concept with the help of classes. So I'm going to name my contract my magic number. Now you can start creating variables. So uint is basically your unsigned int, and I'll give it name as number. I'll create a function, and this will be a getter function, get num. It will not take any arguments. First let's just create a setter basically. So I'm going to create set num, and it will create a number. It will get a number as arguments. This number will be passing from our Web3 or your web app. And so now we need to specify our access modifier. Basically Solidity has 4 access modifiers: public, private, internal, and external. Public is basically accessible from anywhere, inside the contract, outside the contract. Private you can access only within this contract, my magic number dot sol, nowhere else. Internal is basically for accessing inside this contract and any contract which inherit from this contract. External is strictly from outside, you cannot call from inside this contract. So since we will be calling this function from our web app, so let us say this external from now for now, and we'll set the variable num to our number which will be receiving. Similarly, let us create a new getter function. This will not have any parameters. Let us also make this external, and we can have multiple modifiers. This is the access modifiers, and there are some other inbuilt modifiers also, and you can create your own customer modifiers also. So one of the modifier is view. So this tells the blockchain basically that your function will not change any state of your blockchain. It will only read the data from the blockchain. So we'll mark, so since we are reading the number num, we'll mark this as view, and this needs to return a value, so we'll say returns uint. So we need to specify only the type, since Solidity is statically type language, and we'll simply return num. Right, so this is a very basic, like, bare bones of the smart contract. We are just setting a number and getting a number from the blockchain. And also remember, this is the as you call your instance variable, so this will be on the blockchain permanently. And so now we have completed our contract. Let's go ahead and try to compile it. I'll go to number play directory and simply write truffle compile. So this will be only be compiling my changes. So since this is a new project, it has 2 files, contract migration and my magic number, and it is compiling both. And after this, if I make any change to, let's say, this magic number, only this contract will be compiled. All the older compiled contracts which don't have any change will not be compiled. So you can see compilation is successful. Now if you want to test against a blockchain, you don't want to go to your mainnet Ethereum main blockchain, you can actually get a blockchain up and running on your local system. So for that you need to search for ganache CLI, or mainly ganache. It has a UI version also. So ganache will provide you your own local blockchain environment for testing purposes. So I already have it installed. I'll just say ganache CLI, and it will start the local instance of blockchain on my system, and it will also provide me 10 accounts with around 100 ethers each for testing. Let's go ahead and deploy or migrate our contract to the blockchain. I'll say truffle migrate. Now one thing to note is that this private blockchain, as you can see, is listening on localhost 8545 port, but our truffle is looking for the Ethereum client on 7545 port. So I think 7545 is the port for your mainnet, but for, or maybe I don't know. And if you want to change the port, basically you can change the port for Ganache CLI also to 7545, or I just simply change the port for truffle which port truffle is looking at. So you can do that in truffle config.js. Just go to networks and here you can see development. So just uncomment this. So now truffle will start looking at this 8545 port. So they have already configured this. You just need to uncomment it and save. Now we have saved it. Let's try to migrate again. Now it should look for 8545 port. Yeah, so now our deployment is successful and you can see total deployment is 1, right? But only migrations are deployed. But we want also to deploy our contract, my magic number. So to do that, next we'll go to migrations and create a new file. So this initial migrations is for migrations. To deploy our custom contracts, we need to create a new file, deploy contracts.js, right? And we can copy the syntax from here, const your my magic number is equal to artifacts.require and your contract name, which is my magic number. So I also don't understand this completely, just so we only need to do it once, so don't worry too much about this. We can just use this as a template and copy it. Although if you are interested, you can Google it and find more details about it, what is actually happening. So exports function deployer dot deploy and my magic number, right? And if you want to add more contracts, you can just do it here, declare constants and deploy, right? And semicolon. Let's go ahead and save it. Now let's again try to deploy, migrate. So I'll just once restart it. So it is again up and truffle migrate. Now the total deployment should be 2. So you can see total deployments are 2 and my magic number has been deployed. You can see all the details here, and you can see there is a gas price to deploying, there is a total cost to deploy. So now you can see your balance had reduced because there is a cost to doing operations on blockchain. Now our contract is deployed successfully and it's ready to be used through our web app. So currently we'll not build like a very hefty web app. I'll just create a index.html file, and to interact with your smart contract you need a library, Web3. You can also install this through npm, but I was having some issues. You will also find a bug, GitHub bug relating to the issue if you also face the issue. So I am just using this web3.min.js for now, and I'll just copy it to my project, that is number play, paste it here. right? Now I'll start with HTML, and if I just press enter, it will give me a nice head start. So title I'll give number play dap, and we want to include the script, web3 script basically. So web3 dot min dot js, right? And close script. Next we'll do script. So we'll create a new variable. So I'll create a new variable web3, and so now what we want to do is we want to specify a provider basically, from where a blockchain provider, where our blockchain is where our contract is deployed basically. So to do that we have three methods. One is to use browser like Mist, which has inbuilt support for blockchain. So we can use window.getProvider and it will inject the provider. Second is if you are using MetaMask, you can also do that. But since we are not using anything for now, we are just using ganache, so we can do that using this statement web3 new web3 providers http provider, and we'll give the localhost instance 8545. This is where our blockchain is running and our contract is deployed, right? And I'll just do close script, right? Now we have the blockchain instance. Now what we want to do is we want to declare two variables to interact with our contract, and one is the uh, let's say my magic number ABI. So ABI is basically the structure of your contract and what all method it has. So you can find it in JSON. This is created after the compilation, so you can just go ahead and copy it and paste it here. So there are other ways to do it also. This is just the basic easiest way to do, I think, and going forward we can also connect it directly to this file and pull the ABI from here. And next thing we need is the address of the contract. So we'll create a new variable my magic number address. So each time a contract is deployed, it gets a unique address. You can see the address, contract address is listed here. I'm just going to copy it, paste it. Right now I'm going to create var my magic number. So this is the instance which will whereas this is the variable which will get the instance of my deployed contract. So I'm to do that we need web3 from here, the provider dot eth dot contract. So we need to tell it what contract. So our contract is my contract ABI dot where it is located. So we'll tell why at my magic number address. So after doing this, we'll get the instance of your contract in this variable. Now we can start using it. We can use this my magic. Also one more thing, we want to set the default address which we'll be using. So we saw here ganache CLI provides it with multiple addresses. So we need to tell it that which address to use. So we'll say where web3 dot eth dot default address web3 dot eth dot accounts. We'll just use 0. So all the accounts are stored in this accounts array. We'll just use the first account from that. That will be our default address. Now we can go ahead and start using this instance my magic number dot. We'll call our setter function set num and give it any number. Now we want to see the output. So for now we'll just do console.log and afterwards we can implement UI elements, and also these inputs we can give through UI, and we'll do my magic number dot get num. Right, go ahead and save it. Now I want to open this file, so reveal in Finder, open with Safari, see the console, and we have an error, can't find variable web3 source equal to web3.js. I'm going to reload it, can't find variable web3 invalid address. Sorry guys, this will be a default account, not default address. Go ahead and save it, and boom, you can see 9 9 9. And if I go ahead and change this to 999, save, reload, you can see triple line, triple line, triple line, bitch, you got served.